Hello everyone and welcome to this webinar. Well, first of all, I would like to thank you very much for investing your time with us today. My name is Monicelli and I'd like to introduce you the webinar presenter, Rafael Shirakashi de Souza. Rafael has an extensive experience working with us at WEG Automation, and today he will talk about SoftPLC. In this presentation, Rafael will explain it in more details, how to access the tool, as well as the potential benefits, finishing up with an example of use. Okay, moving on, let's touch base on a few housekeeping points. To ensure a good sound quality, all the microphones will be muted. If you have any questions, we would like to hear from you, so feel free to type it in the questions and answers chat. Our team is going to reply your question during the presentation. In case you miss any important point, don't worry. A recorded version of this webinar will be made available, so you can watch it again later or share it with your contacts. To do so, just access WEG's LinkedIn page and click on Events. There you will also find this webinar, past webinars, and the future ones from all the WEG divisions. Also, you can follow us on LinkedIn and also on YouTube, so you can receive the latest news about WEG, our products, and all the different solutions we have for you. So again, welcome, and now it's time to pass it over to Rafael. Enjoy it.
Thank you very much, Monicelli, for the kind introduction. Hello, everyone, and welcome to this webinar. Today, it's a great pleasure to get you guys on board with us. Today, spending your time and investing this time to learn something new. So, we will talk about the soft PLC and how you guys can benefit from that on simple processes automatization, right? So the intent here is to bring to you guys the information on how this amazing tool works, and also a little bit of a direction on how to use it and how to get the best of it. Okay. So before we start, let me introduce myself. So my name is Rafael. I've been working with WEG for the last 14 years. Part of these years here in Brazil, a few other years abroad in Australia. And today my role is as a sales engineer and for low voltage drives and controls. And I'm based in Brazil. Okay. So before we start, I would like to show you guys a little bit of the agenda that we have for today. So you get to know on which stage we are of the presentation itself. Okay, so let me get to the agenda. Okay, so we will start with the soft PLC fundamentals. So in this topic, we will learn what is the soft PLC and also what is the basic operation method to that. Then we'll jump to the second topic. The second topic will be about the WEG's equipment compatibility. So in short, in which equipment you can use this tool, right? Then we're gonna jump to the third topic, which will be the soft PLC interface. So it's actually how you can connect your computer to the equipment and use this tool, right? And then we're gonna finish it up with a programming example. So we have an example here to show you guys how to code, and I'm gonna do it with you during this presentation. Okay, so let's get started. So let's start with the fundamentals. So what is the soft PLC? So the soft PLC is a feature, or let's say a tool that brings a PLC functionalities to that given equipment. In our case, it can be an inverter or a soft starter or any equipment from WEG, which does carry the soft PLC function on it, okay? And that eliminates the need for an external PLC when used for simple applications. So basically it's a tool where you can get your PLC code onto it. So you get your PLC code on the drive itself. And with that, you don't need an external PLC attached to the drive, right? Now that we know what it is, you must be thinking, why do I need this? Huh? So in other words, what is the advantage on that? So I get the main advantages put down here just to show you guys as well. So number one is that you reduce your hardware cost with an external PLC, right? So if it does eliminate the need for an external PLC, so you don't have to pay the cost for that external PLC as well, right? Number two is it reduces the required spaces on cabinets. So in this example here, you have the cabinet with one drive on it. If you need another external PLC, you will need to fit this external PLC to the cabinet itself, which in general means larger cabinets, right? And if you think about ventilation as well, it means you need more ventilation to those cabinets when you have an external PLC, simply because the PLC will generate a little bit of heat, and you have to dissipate that heat as well, right? So in the world we are today, where efficiency is it's an important point, that means more efficient cabinets as well. Okay. And this also eliminates the cabling between the PLC and drive. So if you have an external PLC, you need to wire that external PLC to the drive itself. You don't need that when you can integrate all the functions in only one unit, right? And particularly, I don't like when I have a PLC with a code and I need to access that code and I don't have actually, and the software itself is not for free, right? So for me, it's very convenient, this a free software, programming software, which we have. So all the interface, and we will talk about this later as well, but all these programming softwares from WEG to use SoftPLC, they are for free. So you can get it from our website, download it for free, and it's good to go. Okay, so for me, this is a very good advantage as well. Okay, so now we know what is a soft PLC. We know also the main advantages. So let's get to the basic operation. So how does the soft PLC works? So it's in very simple words, you're programming, or you can program your code onto this soft PLC function, and this code will be in ladder. Okay, so for the ones that are programmers, ladder is a very known language in the market, and that's how you can code your codes onto the soft PLC, right? So what you do, you will record this code internally to the product. That could be a VST or a soft starter, and then you will also emulate this code via the product. So when you code it, you have to give it a go to start, and then the inverter or the product itself will run that software or that code that you built. And then internally to the drives, we have a few variables which can be used in this code. And you can also use all the IOs, which is a short for inputs and outputs, to do your code. So you can use that onto your program. And also you can read and write some of the things from your network and use that as well onto the code, right? So it's a very complex tool. You have multiple options to use it and to code it, and you can use as per your convenience. Okay. So guys, I think we are pretty much done with the fundamentals. So we know now what it is, how it works, what is the basic operation method. Now I think it's time to talk about the equipment compatibility, right? So we will learn now in which equipment you can use this tool, right? So I got a shot. This will be fairly simple and easy, let's say, because of it's you can use the soft PLC in majority of WEG's drives and WEG's soft starters as well. Okay, so in this slide you have all the items you can actually use that with, and in a few of these items, you will need an accessory to connect your USB port from your computer to the device, right? And in a few others, you have a tiny USB port onto the equipment itself. And then it's just a matter to connect your USB cable to the drive and start communicating straight away, okay? So just an important point to note that eventually you may need an external accessory converter to get your computer connected to the device. All right, so moving on, guys, let's get to the interface now. Okay, now let's talk about the software interface. So we have basically two different softwares to do the interface between your computer and the product itself, which you're gonna get your code onto. The first one is called WLP, which is a short for WEG Ladder Programmer. And we have another one as well, which is called WPS, which is a WEG Programming Suite. Okay. Today I will focus a little bit more on WPS, which is the latest software, if I put it that way. And but I will touch base quickly on the WLP as well, so you guys get a taste on how it is, right? And just for your convenience, I got as well these QR codes, which you can scan with your phone or your tablet or your computer, and it will give you guys the link to download the software itself from our website. Okay, but if you don't have that, don't you worry. Just jump to the website. You can type it in WLP. It will get you straight to the page. You can download it. It's very intuitive and easy to find. Okay, so let's move on to the ladder programmer, which is the WEG WLP. So to do that, I guess the easiest way to do it is by actually using that. So let me open the WLP, which is this one here. Okay, so when you open the software itself, you will have something like that. So you can open a project or you can create a new project, right? I'm gonna create one, give it a name. You can give the name of your drive tag number or something like that. Let's pretend this is a tag number, so G23 switch room and the equipment AQ233Q. Jesus, I prefer in capital. And then I'll get roll pump. Cool. And let's say this is the CFW11 and the version itself. Okay. So this is how it looks like. I'm gonna put in a full screen just so you get a better view of the software itself, right? So this is how it looks like. You will have a blank page where you can create your code, and then you can start creating your code with the functions you have available in here. Okay, so what I can do something like that just to get a little bit better organized. I like to organize stuff this way, but anyway, on the top here you have a few menus as well where you can save backups to be used in the future. And look, guys, I'm going really quick on this one just because the focus today is on the WPS, but I guess it's quite intuitive as well. I would encourage you guys to give it a go and try using that, right? So to create, you just can sort of get this one here, for example, normally open contact, and I'm gonna get a coil in there. I'm gonna get a normally closed as well, just in cases. And for example, I can connect the dots using this, right? And then if I double click on the normally open or any block, I will give you guys the properties of that given block, and then you can choose what you want. Okay, I'm gonna leave it as normally open, and I will use this normally open as a system marker as a general enable. Okay, and then I use this one as normally closed now, and I address that to a digital input number 2, for example. And the coil I can address to markers, or I can address as well to system markers or user parameters and stuff like that. And I'm gonna say, well, for this one, it's a run stop command. Okay, so in short, what this line is saying is that when you have a general enable enabled, so this will be closed, then and you have the digital input off, right? So when it's off, this will be closed as well. You give it a go, you give it a run command to the drive, right? If the digital input is on, this will be opened, so you don't have then the run command. Or either way, if you general enable is off, this will be off as well. Okay. So guys, this is in short how it works. I don't wanna, as mentioned, I don't wanna go too deep on the WLP. It's quite intuitive. I think it's time now to close this one. Do you wanna save? No. And let's get to the WPS now. Okay, so similar to the WLP, to the WPS, I'm gonna open as well the software, so we give it a go. So the WPS, let's use it 2.6, version 2.6, and then it is opening. So it does take a while just to load a few of the modules. So because I was using before, it opened in different ways. So I'm gonna close this one. I'm gonna take this test off, right? So let me delete that to start from scratch. All right, so this is from scratch. So when you open the software, it will open this way. Eventually, you might have notifications in there to get your system upgraded, right? So when we have news or when we have new modules or stuff like that, and you are connected to the web, then the WPS will communicate and will say that you need to do upgrades. Okay, so in this case, I don't have any, right? So what I'll do, I'll just shut this off, right? And I'll start a configuration file. Okay, so guys, I have in my computer, I have a SSW900, which is soft starter connected to my computer. So I'm gonna use that. Okay. So when you create this configuration file, which is quite as a folder, you'll see when you open that, it will give you guys a few options. Okay. So again, I'm gonna get the configuration name. I like to put tags on it. So 1, 2, 3, 4 dash switch room 56 dash 78A, which in this case will be a compressor. All right, compressor 1. And use the resource name as SSW900. Wait, give it a go, give it a next. So I know what is the device, so I'm gonna get the SSW900 in here. I like to test that before. So it is saying that the device is online. So good to go. I'm gonna hit next. Okay. So now the system is creating all those folders. It can take a while. And here we go. We have the SSW900 connected. It's giving me the version of the software. The one that I have is fairly old, so it's 1.2. I'm gonna hit next. Okay. So when you hit next, you get to this page where you can actually import a WLP, which remember is the software we were talking before, backup. So if you have a backup from WLP, this is the time where you can actually load those that file to this configuration file. Right? I don't have any, so I will leave it in blank, and then I'll hit finish. Okay. So you can see that now we have the compressor one in here. It's a folder, right? So just so we can see that better, I'm gonna make it full screen as well. And I'm gonna open this one. So that's equipment WAG, right? And then I have different folders onto it, right? This is very interesting. I can open, for example, the folder parameters, and if I double click on parameters, it will open me all the parameter files in there, right? I have like an icon in there to connect to the device, so I can use a shortcut, which is F9. I'm gonna connect to the device. So what I have here is your online data, right? So if I change it in here for 240, for example, right, it will change up there, right? So if I change the current to 5 amps, for example, this is changing online, this information onto the soft start. So instead of using your HMI, this is another option to get the parameters configured to the device itself, right? So I find it very helpful. Sometimes you can also edit and save. You can save different versions as well of the parameters. You can create another one in here with your right button. You can rename it. You can copy and paste. So there are a few options with that. Okay, guys, so now that we finished with the parameters, let's move on and I'll show you the wizards, okay? I think it's a very interesting tool as well. Let me open this one up so you can get a little feeling on how it works, okay? So this is how it looks like, the wizard. So you can actually see the graphs and how to get your parameter settings onto this data as well. Okay, so because we are talking about soft starters, this will bring the information on the software starters. But if you have an inverter, for example, then you will have different options in there to reflect to the inverter operation, right? So in this case, I can change it for a voltage ramp, for example. And here I can change what is the initial start voltage level from 30 to 40, for example. I can set up what is the starting time. It was 20 seconds. I can get 50 seconds, for example. Then I can check, I can change also a few of these options on the starting and stopping. If I move to the tab motor data, that brings a visual picture of the motor nameplate. In this case, we have a W22 example, right? And where you can gather information to each of these fields, okay? So it's very intuitive as well. It's easy to find. Then we get to another tab, which is the local remote selection. This is basically how you set up your starter automatization, let's say, when it's in local, what you will do, how you're going to give the commands to start and stop. This is done via this tab. You can also set up your IOs, okay? There's a graphic very, for me, this is very intuitive as well, because you can see exactly how to connect your IOs, and you can give the functions of those IOs through here as well. And then the last one is pretty much if your connection is inside Delta or not. If it's inside Delta, it will change the graph. You basically know how to connect, how the terminals should be connected as well. with the motor, right? And then, well, if you have like different types of motor, you also will give you like this graphic representation in your connection points as well. Okay, so for me, this is a very intuitive tool. It's bulletproof, so it's good to set up through that as well. Just in case if you're having difficulties on visualizing how to set up via the HMI. Okay, so good tool on the WPS. I won't save it because we're not actually doing that. There's another diagnostic folder on that you can actually train or make your trains. You can give it a new file, say, okay, this is a train number 1, finish. And then when you open this train, you can add channels to that, right? And those channels can be different things. For example, variable number 1, I can get a status of a digital input, for example. Okay. The variable number 2, I can look for current. So initial current or configuration is not configuration. I'm after status measurement. So current on phase R. So this is in there, right? And then if I am connected, yes, monitor straight away, I can train that. Because my soft start is not running at the moment, it's all in 0, right? But if I change the status, then you will have the information in there. You can change the sampling time over the top or the time span as well. Instead of 1 minute, you can get like 15 minutes. Then you can stop and close as well if you want. Do you want to save? Yes. Okay, that's saved. And if I open again, you get the saved trained onto your file as well on this big folder with this information from the soft start. Okay. So again, this is a very good tool when you're commissioning your soft starter or your equipment because you can save the trends. You can, for example, you can rename this for like this is the 1, or you can put O1 first first start, for example, and then you have that information how the first start was. You can rename it, and that's a few of the tricks that I've learned along my way. So you can put O1 and you can put a year or a date, right? So you can say, well, this was on the December 21, for example. December 21, first start. And then along the lifespan of this product, if you connect again in the future, you can save another trend and then you can compare as well how it is doing, right? So a very good tool to use. Then there's a few other things, the logs. Well, it's pretty intuitive as well. You can load these alarm logs from the product. Then you can rename it. It will bring like a few information in there, but you can also rename it and you can also delete it if it's the case. Okay, if say, okay, I don't need that, it's too much information, you can delete this information as well. Okay. And then the same works with faults and the event logs as well. So diagnostics is a good folder to keep track on how the equipment is doing, and very good as well for commissioning when you can train the data that you after, and you can get like the best setup as possible for your application. Okay. And now let's move on to what is the intent of this presentation, which is the ladder. So I'm gonna open the main ladder screen, right? It opens it something like that. I'm not gonna connect just because when it's connected, I can't actually do any change, but I'll disconnect that and then I'll have the space to to do my code. All right. So this is how it looks like, right? So when you first open it, you have only a single line. Important point, when you need to add the lines, you keep adding lines like this, right? And then you can also delete lines like that, right? So I'm gonna add this line. How you do you remember the WLP where you put the blocks and then you connect the dots? In this one is slightly different. You have the dots already connected, and then you put the blocks onto that or in the position you want, right? And all these blocks, they are in this palette, which is in your right side, right? So those are the options you have to code or to use in your code, right? So you have coils, you have comparison blocks, you have the contacts, you have in controls, you have the PID controls. So you can do data transfer, you can do mathematic functions, you can use timers, and you can use ITC modules. So there are a few options in there, right? So the way it works, we just get one. I like to get context because it's, well, we use fairly a lot. And you can just leave it there. And I can use another one, leave in there. And then I can finish it up with a coil, for example, right? So this one didn't go. I'm gonna place in there. So you can see the red dot, which is the end of the line, and then you need just the coil after that. And well, okay, so we have all the blocks and the coil itself. And how do I address? I have to double click on it, and that will bring a few options. Okay. Note that for the soft starter that I'm using today, just out of convenience, I have not as many options as usually I have in the inverters, but I have a few. So let's say if I want to set up something similar to what I did before, I can set up this as a run command. So it was actually run. I'm going to take this off, get the option. I'll type it in. No, I will get run stop, right? And I can identify this as a digital input, for example, and identify this one as a eventually digital output, who knows, okay? So in this case, when digital input 1 is closed, digital output is closed as well, I'll have the run command to the soft starter. All right. So this is how it works, guys. So it's pretty simple, pretty intuitive. What I will do, I will continue my presentation because we will get back to this point because we're gonna do this a programming example, and then we will learn, or we will do one example together here just so you guys get to understand a little bit better, right? But in general lines, this is how the WPS looks like. As I mentioned, very intuitive, very simple to use. Okay, so let's move on to the programming example. First, I would like to show you guys what is the example that I have for you today, which is this one here. So this system is pretty much getting random boxes and then separating these boxes, the metallic ones to the top, and then leaving the plastic box to pass through directly, right? And then the system will also count the number of boxes and stop it when this number gets to a certain number, right? So let's say if it accumulates like 5 boxes in here, then you have to stop the conveyor itself. All right, so we have here Pinometric Actuator, which will then move these boxes, the metallic ones, to the top, and it won't do a thing when you have the plastic boxes, leaving the plastic ones to pass through straight, right? So we will have then a few sensors around. So one is the metallic box detector, we will have as well the counter for the metallic boxes and also the counter for the plastic boxes, right? And then we will need also to operate this pneumatic actuator just to do the boxes movement, okay, during this process. And to do that, we will have a few inputs and a few outputs as well to the system, right? So let's start with digital input 1, which I'm addressing to a general enable, okay? So this will enable the drive to run. And then we'll have like a start command, right, on digital input 2. Digital input 3, I addressed as the metallic box detector, right? When we go to digital input 4, that will be your metallic boxes counter, right? So this will count the number of boxes that pass through. Digital input 5 will do the same, but with the plastic boxes. And then we're gonna have 3 different outputs. So digital output 1 will be the one to give a go command to the pneumatic actuator. A digital output 2 will be a buzzer, which will be on when you have the number of boxes in the end. And then I'm addressing digital output 3 in here to give the go command to the motor, right? The thing is, I have a soft starter to operate the system, but I can't actually run the soft starter without any load on it. So instead of running the soft starter, I'm gonna use digital output 3 as just to give you guys an idea when the motor should or shouldn't be running. Okay. So those are the inputs or the variables we have to this code. So we need just to code that onto WPS. Okay, so let's move on. The way it works, this tray will be running. Okay, the metallic box detector detected that this is a metallic box. So it will push that way, coming back. Okay, it's not metallic, pass through straight. So again, let's show you again. So this will be running and then, okay, metallic goes to the top, no metallic goes straight, and then this would stop when you have a next amount of boxes either way. All right, so let's again open the WPS to do that. So let's go back to the WPS. This is the WPS. So let's do it. So what I'm gonna do, I'm gonna reduce this one here just so you guys can actually see what I'm doing, right? I'm gonna get this here. I'll close this one up. I will then get to show you the IOs. Okay, so in this little window here, you will see how I can force the IOs. I just wanna get as well the palette so we can get the data on it. Let me give it a connect. I'll disconnect. And now, yep. And now, what we'll get as well is a photo or picture of the application and also the IOs. So we get to know which one is which. Okay. So, okay, let's get it started. What we'll do first, let me remove this old software and we can start with the new one. With the new one, we have digital input 1 as a general enable, right? So what I'll do, I'll get a general enable actuated via digital input 1. So I'm gonna get this and this. This one here, I'll address as general enable, which is CMG general enable. And then this one here, I'll address as digital input 1, right? Cool. So what I can also do is write in here, this is the general enable line. Okay, so we have the general enable. Now, what do we need? We need to get the start command operating, right? So, which is via digital input 2. I'm gonna get digital input 2 in there. In this case, I will interlock as well with the general enable, right? So I'll get a second set of contact in there. So this will be my digital input 2. Digital input 2. Choose that. This will be my general. Let me find it in here. My general enable, right? And that will actually get to my run command. So my run command, remember, we're going to consider digital output 3, right? So I'm going to get this one as GO3. So GO3 will show me when it's running, when it's not running. So I'm going to another line. Okay, so we get the general enable, we'll get the start. Now, we need, well, the unit is running. So what we need to do, we need to actuate the pneumatic when there's a metallic box onto it, right? So before we go further, I'll get the start. This was the start command. Cool. So this one will be then the metallic box identification and the actuator, right? So to actuate that, I need the digital input 3 to be closed, right? And the unit needs to be running as well, right? So I'll get one here. And because it needs to be running, digital output 3. So it has to, hold on, digital output 3, because it has to be running. I'll choose that. The other thing it has to happen, it has to get the detector. So digital input 3 needs to be closed. And when you have this and that running and a metallic box pass through, then you actuate digital output 1, right? So before we simply actuate, what we do, I'll have a timer, right? To before, so we wait a little bit until we get through exactly the moment, right? So I'm gonna say this time should be like 1 second, right? So I'm gonna get one. Hold on, let me get first the second. This will be in second, and this will be 1. Enter. So it's gonna take 1 second, wait 1 second, and then I'm gonna close the actuator, which is digital output 1. So let me get a direct coil. I'll probably get a set coil, because once this is closed, I need to, you see that, right? So this is digital, then output, digital output 1. Ooh, output 1. Okay, so let me move this a little bit further this way so we can see that. All right, so let's move on. So after 1 second, so what I can do as well, I can send it over this information to the drive and give it a go, right? So let me do that. No, is this one here. Let me build the resource right to the soft starter. Okay, this action, yes, okay, right? And now it is reaching into the device. I'm gonna connect there. Say okay, yes, okay, run the software, right? So let's see, when we close the digital input 1, right? I'll just, because it's forced off, I'm gonna force it on. So you see, when I close digital input 1, I got the general enable. You can see that. So if I open digital input 1, I don't have the general enable anymore. So when I have general enable on, and then the run command, I have digital output 3 on, which is our run command. So the motor is running now, right? And then when I have one metallic box passing through, right? So it's passing through, took 1 second, and then it closed number 1. So it is actuated. Now I need to actually to count these boxes. When these boxes pass through this metallic counter, that's the time which I can turn this one off to release and come back to the original state, right? So let me take those offs. See, it is still on because it's a set coil. But to continue the software, I'm gonna disconnect, right? And I'll add another line. So in line number 4, we are going to the no. We're going to the counter boxes. Let's say metallic boxes counter. Okay. So how does it work now? When my digital input 4 is on, it means the boxes has passed through, right? So I'll get a digital input 4 in there. So digital input 4, I'll choose that, okay. And then what do I need to do? I need to count after a few times. That's when I will stop, right? So if it counts like 5 boxes in there, then you will stop the whole thing and shut the buzzer on, right? So what we will do then, we will have to get a module to count that. So I'm gonna get a counter, right? And I get a CTU. I need to set up a reset as well to reset when I want to restart, right? So I'll say the reset is digital input 6. So this is a reset button. And this is the number that I would like to count. I'll put 5 times, right? And after 5 times, what you will do, you will check the GO3, hold on. After that, what we will do, we will have to stop the whole thing, okay? So the whole thing is running because of the GO3, right? So what I'll do, so I got a glitch in my software. Instead of a simple coil in here, I need to get a set coil, because I'm gonna set this coil here. Let me take this off. I'll get a set coil instead. So this is GO3 to run. So once it's running, you just need one pulse and it will start running, and then you need a reset button to stop running. So I'm gonna reset coil here now for the digital output 3, right? So this will stop the whole thing. Also, you can, well, I think that's all. GO1, which is the Pinometric. Okay, so we need a GO1 as well to reset. But let's see how it works. Let's see how it is doing. Let's build it. Okay. Okay. Let's connect. Yes. Run. Okay. Yes. Okay, it's running. So general enable. Then run command. It is running, okay? So it's running, I'm getting the boxes. So let's say this is a metallic box, okay? It's a metallic box, digital input 3. Okay, the actuator now has actuated, right? And GY5, oh, it's false. So what is I4? When I have GI4 for 5 times, 1, 2, 3, 4, and 5. Okay, 5 times it passed through. Okay, and stop the motor with the reset coil. Can see that? So the counter is working well, right? The only thing which is still not working is to return this actuator. Okay, so now we have to fix the actuator which is not coming back, right? So to the actuator come back, we need to get the boxes through the digital input 4. So let's add another line and let's name this as actuator returning, right? So it will return after my digital input 4 is closed, right? So what I'll do, I'll name this as a digital input 4. And then I'll get a reset coil because I used digital output 1 as a set coil. Now to release it, I'll use a reset coil. So this will be digital output 1, which is the actuator, right? Cool. So the actuator is now returning. So we have the counter, we have the actuator going and coming back, we have the start command, general enable. The only thing is missing is the counter for the boxes, right? The cartoon boxes. So the cartoon boxes counter will be quite the same as the metallic, right? So what we will do, I'll get this line and I'll try that. I never done that. I'll copy that and then I'll add another one and I'll paste it. Doesn't. Okay. Let me see if I can. What is this? Rung or select group. Select group of elements. Okay. Yeah, I'll give it a Control C and then I'll give Control V. Beautiful, it works out. So let me remove the line number 6 minus, and then I'll change the name. Instead of a metallic box, this is cartoon boxes counter. Okay, so when I get, instead of a digital input 4, is digital input 5 now, right? Digital input 5. And then again, I will count up to 5. I'll change it to 3, just so we make it easier and quicker to test it. And then again, I'm gonna reset coil to digital output 3, right? Cool. Now there's one thing which is missing, is the buzzer, right? So every time I get to 5, I need to get the buzzer. So I need to ring that buzzer. So buzzer actuation, right? So the buzzer is digital input 6. So what we will do when digital input, now digital input 6 is the reset. So the reset will take the buzzer off. So I will need reset digital input 6, right? So if I have a reset, it will stop the buzzer actuation. And also when I get this finished or this finished, that will give me a contact, right? So what I'll have to do then, I'll have to create a buzzer signal. So, and use a set coil in there. So I'm gonna use a set coil in here for the buzzer. And this I will name as, I don't know if I can name that. Yes, I wanna create a buzzer. And I will do the same here. All right, and I'll name this, whoops, come on, buzzer. All right, and when I have the buzzer, then I will close digital output 2, right? So I'm gonna get digital output 2 in there. Beautiful. Then I have the buzzer actuation, right? Digital input 6 is the reset, right? So, and every time that I reset the buzzer will come off. Well, it should work. So let's build the resource, give it okay. Oh, one error. This is already used block. Okay. So I'm using the same block here. I need to change it for 1. Yes. Let me see if this will work now. Because I copy and paste. So, okay. Download it anyway. So let's do that. Emulate the code. And run the program. Okay, oops, I need to unforce these ones. Cool. So let me connect now. So let's say I'm gonna start. I have the general enable, beautiful. General enable is in, and then I decide to start running. Okay, give it a go. Motor is running, boxes are running. Oops, there's a metallic one. Okay, digital input 3, metallic. Then I get the actuator actuating, right? The metallic box is gone, right? And then I get the counter for the metallic box, counting 1. Beautiful. It counted 1. Look, this is still running, right? And then I get the next one. So I got the counter here as 1. So I get the next one, and the next one, let's say, is a plastic. So I don't have the actuator, plastic, right? Off. Yeah, she's done 1. Third one is plastic. Okay, plastic, done. Then I have another metallic one, right? Actuator started, done, and then I get the counter, right? Cool. So I have 2 and 2. Now is the last one. Let's say the last one is metallic, okay? So it should close the motor running. So it's not 6. 6 is reset. It's I reset it. I reset everything because I have the reset in there. So let's start again. 5, 1, 2 boxes, cartoon boxes. And now let's get to the third one. Third cartoon boxes, the buzzer is on, right? So it's closing. The buzzer actuated. The buzzer is not doing anything, right? So this needs to be normally closed, right? Instead of a normally opened. So I'm gonna get a normally closed instead. Oh, have to disconnect, delete. I'll get a normally closed contact in there. GI6, which is the reset. Cool. We're gonna emulate again. Build resource. Okay. Download it anyway, because it's just mentioning to me that there's one running software already in the unit. I said, okay, run it anyway, download it anyway. Okay, run it. So because it's forced, it was still there. So I'm gonna, okay, one box, two plastic box, a cartoon box, sorry. Third cartoon box. Okay, the buzzer, it's making noise. Right. I'll take this off. And to reset that, I need to use the reset button, right? So if I take the run command off and reset, okay, it's reset. So the thing is not running, right? And the buzzer is off as well. Okay, so in general lines, this is how it works out. So you can see the motor is not spinning, digital output tree is open. So this is how it works. This is a very simple code, but I hope you guys had an opportunity to experiment that and to see how we usually build this code. Okay, I know there's a few glitches on my code for this application itself. Usually it's not that simple, but this is generally how it looks like, okay? So the intent today is not to get you guys professional programmers, but just to let you guys know what are the possibilities and capabilities of this code itself, okay? So guys, I guess we are getting close to the end of the presentation. I'm gonna go back here and think now is time for questions. So we're getting to the end of this presentation. Now it's time for you guys to get all the remaining questions, let's say, to our team so we can respond those accordingly. I would like to encourage you guys as well to access our website. There you will find complementary information like the menus and stuff like that, right? Also, I would like to encourage you to download the WPS and give it a go. Try using the SoftPLC. You will see it's not that complicated. It's fairly simple, and I'm sure that you guys can somehow benefit from that. Okay, so season greetings to you all. I hope you guys have a good end of the year with your families and a good and safe end of the year with your families and the loved ones. Okay, so I'll talk to you again probably next year in another webinar. See you later. Bye bye.